we are going to prove that the derivative of sine theta with respect to theta is cosine theta. But in order to do that, we have to do something which at first seems unrelated, perhaps, but it's an important part of the proof. As a little aside, we're going to prove that the limit as theta goes to 0 of sine theta over theta equals 1. How are we going to do that? Here's the proof. First, we're going to recall that the area of a circle is pi r squared, and we're going to re-express pi as 2 pi over 2. So we're going to say that the area of a circle is 2 pi over 2 times r squared. Now, we're going to focus in on a little sector of the circle. This pink piece is a sector. And we know that a circle has a total of 2 pi radians, and this sector has a total of theta radians. So for instance, if the whole circle had, let's say, 10 radians, and this sector had 2 radians, we would say that the sector represented 2/10 of a circle. Well, we don't have rational numbers, instead we have irrational numbers. We know that 2 pi will be the denominator, that's the total number of radians, and theta will be the numerator, that's the number of radians in the sector. So this sector represents theta over 2 pi of the circle as a whole, where theta is measured in terms of radians. So the area of this sector is theta over 2 pi times the area of the circle. These 2 pi's cancel out, and we get theta over 2 of r squared. So the area of this sector, this pink sector, is theta over 2 of r squared. Now we're going to consider that the circle has a radius of 1, in other words, a unit circle. So we're going to say that the area of the sector OCD is theta over 2 times 1 squared, or in other words, theta over 2. Okay. Now, the same circle we had a minute ago, this pink sector, it's the same one, that has an area of theta over 2. We're going to draw a little triangle in here. And we know, since it's a unit circle, we know that this point C has the coordinates cos theta, sine theta. And if we drop a height down, a perpendicular height, we see that this, the coordinates of this point B will be cos theta 0. And we can see, it's pretty obvious, that the area of the triangle that I've created right here, the area of that triangle is less than or equal to the area of the pink sector. It would actually technically be equal to it if theta was equal to 0. But it's not. But for technicalities, we'll say less than or equal to the area of the sector OCD. Now we know the area of the triangle OCB is 1/2 base times height. We see that the base of this triangle is cos theta. That's the magnitude of this length. And we see that the height, the magnitude of that length, is sine theta, the y-coordinate. So instead of saying 1/2 base times height, we can say 1/2 cos theta sine theta. So the area of this triangle is less than or equal to the area of the sector, meaning 1/2 cos theta sine theta is less than or equal to theta over 2. Now, what we're going to do next is we're going to draw a circle with a radius of b around the origin. So it'll be a smaller circle, smaller than the unit circle that we have, and you can see it right here. Okay, so we still have the pink sector we had a second ago. We still have the triangle that we drew in, but now we've got this smaller circle, and that smaller circle has a radius of the x-coordinate of b, which is cos theta. Has a radius of cos theta. And as we mentioned 2 pages ago, the area of a sector, in other words this blue sector, will be theta over 2 times r squared. That was something that we said 2 pages ago. The area of a sector is theta over 2 times r squared. And since r is equal to cos theta, we can say that the area of the blue sector will be theta over 2 times cos squared theta. But we can tell that the area of that blue sector is less than or equal to the area of that triangle, which is less than or equal to the area of that pink sector. In other words, the blue sector's area less than or equal to the area of the triangle, and the area of the triangle is less than or equal to the area of the pink sector. So what we can write is that the area of sector OAB, the blue sector, is less than or equal to the area of the triangle, which is less than or equal to the area of the pink sector, OCD. Now these, we already know the area of the blue sector is theta over 2 cos squared theta. The area of the triangle is 1/2 cos theta sine theta, and the area of the pink sector is theta over 2. We're going to multiply all three of these quantities by 2 over theta cos theta. So 2 over theta cos theta times theta over 2 cos squared theta is less than or equal to 2 over theta cos theta times 1/2 cos theta sine theta, which is less than or equal to 2 over theta cos theta times theta over 2. We can simplify. This quantity simplifies to cos theta, this quantity simplifies to sine theta over theta, and this quantity simplifies to 1 over cos theta. Now what we're going to do is we're going to take the limit as theta goes to 0 of all three of these quantities. So the limit as theta goes to 0 of cos theta is less than or equal to the limit as theta goes to 0 of sine theta over theta, which is less than or equal to the limit as theta goes to 0 of 1 over cos theta. Now remember, when it comes to limits, if you can just plug the value of where the variable is going to, if you can just plug that straight into a continuous function and get a defined value, that's what you should do. Well, we can do that right here and right here. We can plug a theta equaling 0 value right there, and we'll get defined values. So that's what we're going to do. The cosine of 0 is less than or equal to the limit as theta goes to 0 of sine theta over theta. We didn't plug a theta value of 0 in here, because if we did, we'd get 0 over 0, so we can't. And but we can plug a value of theta equaling 0 into the right-hand side. And so cos 0 is 1. 1 over cos 0 is also 1. And so we get that 1 is less than or equal to the limit as theta goes to 0 of sine theta over theta, which is less than or equal to 1. And this is called the squeeze theorem. It's pretty cool. The only way that the above statement could be true, that 1 is less than or equal to some quantity which is less than or equal to 1, is if that quantity itself equals 1, thereby making the statement 1 less than or equal to 1 less than or equal to 1. That's the only way it could happen. Therefore, this middle quantity, the limit as theta goes to 0 of sine theta over theta, must be equal to 1. Okay, all of that was an aside. So now what we can do is come back to our proof. And our proof will go a little bit easier now. We're trying to prove that the derivative of sine theta with respect to theta is cos theta. So the derivative of sine theta with respect to theta is just f of theta plus h minus f of theta over h. Obviously the limit as h goes to 0 of that. And we learned in advanced functions a compound angle formula. The sine of a plus b is sine a cos b plus cos a sine b. So the sine of theta plus h is sine theta cos h plus cos theta sine h. And I still have this, we still have this minus sine theta over here, all over h. Now what we're going to do is we're just going to rearrange this a bit. We're going to move this minus sine theta here, and we're going to move that over there, and we're going to break the fractions apart. So we've got sine theta cos h minus sine theta, all over h, plus cos theta sine h, all over h. Okay, just a little bit of fraction work there. Now, we're going to take this limit as h goes to 0. Instead of doing the limit of the whole thing, we're going to add the sum of the limits. In other words, take this limit as h goes to 0, put it there. We're allowed to do that. And next what we're going to do is we're going to factor out sine theta from this numerator, like that. Okay, so we've got the limit as h goes to 0 of sine theta times cos h minus 1, quantity, all over h, plus limit as h goes to 0 of cos theta sine h, all over h. Well, this sine theta has nothing to do with h, so I'm actually allowed to bring it out in front. Sine theta times the limit as h goes to 0 of cos h minus 1, all over h. And this cos theta has nothing to do with it, so I'm allowed to bring it out in front since it's a factor of the numerator, just like that was. And make it cos theta times the limit as h goes to 0 of sine h over h. Now, we know that this is equal to 1. That's literally what we just took 5 pages to prove. The limit as theta goes to 0 of sine theta over theta is 1, so the limit as h goes to 0 of sine h over h is 1. Boom. So we have cos theta times 1 here. Now we've got sine theta times this limit here. So what we're going to do is multiply numerator and denominator by cos h plus 1. In other words, we're just multiplying the whole thing by 1. Okay, you might wonder why we're doing that, but we're setting something up. What we've now got is cos h minus 1 times cos h plus 1 across the numerator. That becomes cos squared h minus 1. And the denominator is h times cos h plus 1. Okay? Plus cos theta times 1, which as we said is just cos theta. Okay? Now, we know that cos squared h plus sine squared h equals 1. So if we subtract sine squared h from both sides and subtract 1 from both sides, that means cos squared h minus 1 is the same as negative sine squared h. In our next line, we're going to replace this with negative sine squared h. And there we go. Now, we've got the limit as h goes to 0 of negative sine squared h times h over cos h plus 1. And that's multiplied by sine theta, and then to that resulting quantity, we're going to add cos theta. What we're going to do is break this apart. This negative sine squared h, we're going to call it negative sine h times sine h. And then we have h in this denominator and cos h plus 1 in this denominator. In other words, if you were to multiply these two fractions together, you would get that. So we're allowed to break them apart like that. So we're also allowed to take this limit as h goes to 0 and move it to here. So we've got the limit as h goes to 0 of this quantity times the limit as h goes to 0 of this quantity. We can take this negative sign and move it in front. So we have negative limit as h goes to 0 of sine h over h times limit as h goes to 0 of sine h over cos h plus 1. Now, we just spent 5 pages proving that this is equal to 1. The limit as h goes to 0 of sine h over h is 1. Well, this limit here, this can be evaluated by simply plugging in an h value of 0. We have the sine of 0 over the cos of 0 plus 1. That's actually defined. So we have negative 1, sine of 0 over cos 0 plus 1. The sine of 0 is 0. The cos of 0 is 1. So we have negative 1 times 0 over 1 plus 1. 0 over 1 plus 1 is the same as 0. So ultimately what we have is sine theta times negative 1 times 0, and then that quantity plus cos theta. That's the same as saying sine theta times 0 plus cos theta, which is the same as 0 plus cos theta, which is the same as cos theta. So we have just proved that the derivative of sine theta with respect to theta is cos theta.